This one is just all about chocolate. Some of it is chemistry, but some of it is some of the cultural stuff around chocolate as well. So important to remember that, chemistry influences many parts of our lives, not just what goes on in the laboratory. So we'll talk about some of those other things that we might think about with reference to chocolate. So you might think of the United States as being a place that eats a lot of chocolate. We are one of the most obese nations in the world overall. We do eat a lot of sugar, but it is extremely popular in Europe. So if you look at this bar graph of who eats the most chocolate, these countries are primarily European countries where it is dominantly eaten. And they tend to like it very, very sweet. So they find American chocolate to be rather bland and disgusting. And so if you get chocolate, if you ever have the opportunity to go to Europe, my understanding, I haven't really tried this, but my understanding is if you get chocolate in Europe, it is much, much sweeter. So I mentioned that there are some different parts to it. Chocolate comes from what's called a cocoa bean. And in that cocoa bean, there is cocoa butter. It's a white fatty material, and that makes up more than half of the mass of the cocoa bean. There are some sugars in there, but most of the carbohydrates are fiber. Remember, fiber is something that we can't digest. So it's still good for us because it helps keeps the pipes clean and moving along, but it's not going to add any calories for us. There's a little bit of protein in there. And then these polyphenols, the flavonols and proanthocyanins and things like that, those are going to be the things that are really helpful health-wise. So if you've heard of antioxidants, a lot of these are antioxidants, and that's how they can be helpful in our health. And then there's some minerals in there as well. So if we look inside the cocoa bean, you can see there's these, so this is a pod, and inside there's these little bean things, and that white stuff on there is the cocoa butter. So they separate the cocoa butter, they separate that fat from all the chocolate solids. So regardless of what kind of chocolate you have, whether it has the fat in it or not, they separate it out. So they just have the cocoa solids, and then they combine it back in the ratio that they want. So those cocoa solids can be powdered down, in which case you might use it for like hot chocolate or chocolate milk. And then you can also mix back in the cocoa butter or leave the cocoa butter separate if you're going to try and do white chocolate. So eating chocolate or candy usually has a higher percentage of fat. And that is because that gives a good texture, a good mouthfeel to it. So the interesting thing about the melting of the fats is that it will melt at a temperature that is lower than your body temperature, but higher than usually room temperature. So if you've ever heard the phrase, it melts in your mouth, but not in your hand, that's the idea, is that when you have that in your mouth, it's right at that right temperature to be melting as you are eating it. And that's one of the experiences that makes chocolate so pleasurable for some people. Mm-hmm. Now, the fats can form lots of different crystals. I actually have, this might be on the slideshow, but I have over here a chart here that goes from 1 to 6. There are 6 different melting points for chocolate. And really just kind of depends on how the fat molecules are fitting together. Are they lining up like this? Or are they turning around like this? Or are they sideways? And depending on which way they go, they have a different melting point. And the melting points 4 and 5, especially 5, is really where we like to have it. That's the one that melts in your mouth. But if it starts forming the crystals of the lower temperatures, you get these fat blooms. Okay, so this is an indication that it is has melted and solidified and melted and solidified. And as it has done that, it has started to solidify at different temperatures. Also, the fat is non-polar, sugar is polar. So we talked about this at the beginning. Oils and lipids tend to be non-polar, carbohydrates tend to be polar. They're going to start separating out. And so you're getting the fat separating out from the sugar there. And so that's how you get those fat blooms. Are they bad for you? No. Do they make the experience less pleasant? Yes. So it's crumbly and not as pleasant, but it's not bad or moldy or anything. Okay, so I mentioned there are 6 melting points. So we call these polymorphs or forms for it to melt. And they melt at different temperatures. When it melts at that, or when we have the crystals at the 5th polymorph, we call that tempered chocolate. So this strawberry was dipped in chocolate that was at a lower temperature when it was molten, and this one was at a higher temperature and was tempered. And so you can see this one's shinier than this one. If you have tempered chocolate, if you get a chocolate bar and you go to break it, you're going to get that nice satisfying snap when you break it. But if you pick up a chocolate bar that maybe has been sitting in the sun and it's still solid, but you go to break it, it's just going to kind of mush and go, wah, wah. You know, that's kind of this. Okay. So tempered chocolate is really what we prefer. That's the phase 5 crystals, and it crystallizes around 33 degrees. And then, like I said, if you have it sitting in the sun or something, it can cause it to start to melt and then re-solidify at different temperatures. So there's whole techniques to getting this tempered chocolate, because you'll start forming the crystals of like 6 and 5 and 4 all at the same time. And so you have to kind of raise and lower the temperature in order to do it. So I think one of the videos that I have, if you're interested in tempering chocolate, is on some techniques to temper chocolate. Okay, so we talked about how it's related to caffeine. Oh, we did not. I don't know why that's there. We did not talk about dogs. Okay, so chocolate is a stimulant. When we eat chocolate, we metabolize that theobromine. And so we change it into molecules that our body can use. And so it doesn't continue to have the same effects, but most other animals cannot metabolize the theobromine. And so for a dog, if they get that theobromine, they get that stimulant effect, and it causes their heart to race. So having giving a dog chocolate is kind of like giving them an instant panic attack. And if you've ever had a panic attack, especially if you don't even know why you're having a panic attack, that can be bad. Like your heart is racing, you're sweating, and like you feel afraid, and you're like, I'm just sitting here, there's nothing to be afraid of. So that can be a really distressing situation. And if you give a dog too much chocolate, it can in fact kill them. So never feed your dog chocolate. Now, you may have gone into, they have special dog bakeries. They sometimes call them barkeries. And they'll have like dog bones dipped in white chocolate. Well, remember I said the white chocolate, they've taken out the chocolate solids. They don't have the theobromine. So it's okay to give your dog white chocolate, just not any kind of darker chocolate, dark chocolate, milk chocolate, that kind of thing, anything with theobromine. Okay, so now that we've talked about this, if you were paying attention, which of these properties is the one that makes chocolate bad for dogs? All right, so most of you said heart stimulant, and that is in fact the correct answer there. Now, I mentioned that most animals don't metabolize the chocolate like we do. And I have cats. And so when I was looking into this, I was like, well, why don't they say, cats shouldn't have it? Can cats have chocolate? Is that okay? Well, it turns out cats don't typically like carby things. So generally, they're not going to be attracted to sweet things. But I have since learned that not only is it that cats don't like sweet things, so they're probably not going to eat chocolate, they actually can't digest sugar the way that we do. So giving your cat things with sugar in it is bad anyway. So don't try to feed your cat sugar or chocolate. all of this is very strange because I have had a cat that loved marshmallows. And of course, marshmallows have sugar in them. And I have since learned that this is actually one of the weird things about cats is that most of the time they won't eat sugar, but marshmallows is one of those weird things that not all cats, some cats like marshmallows, including sometimes animals at zoos. You can find tigers or lions, if you feed them marshmallows, they will eat them. I don't know. You're always hurt by the ones you love, I guess. Okay. So don't feed any of your pets chocolate and don't give sugar to your cats. Okay, we looked at that one already. So, is chocolate good for you? Well, it kind of depends. We've got some things that we like. There are antioxidants. So antioxidants protect our cells from damage. As we do things over the course of the day, some of the waste products of chemical reactions can be damaging. And so they help to clean up those waste products. That's what antioxidants do. So that's good. The phenylethylamine, that's the one that I said, is why people think it might be an aphrodisiac. It's kind of a feel-good chemical. So, you got this chemical thing that's like improving your mood. And then there's the theobromine, which is the stimulant, and it's also a vasodilator, which will lower your blood pressure. So health-wise, it does have some good things going for you. The bad side of it is that we almost never just eat the dark cocoa nibs, the chocolate solids. We almost always have it in conjunction with fat and sugar. So the fats that are in it, stearic acid, palmitic acid, those are saturated fats. Now, we haven't talked a lot about saturated fats, but generally between having saturated and unsaturated, saturated are the bad ones. Those are the ones that tend to clog your arteries. So not only are there fats in there, they're not the good kind of fats. And like I said, almost always when we have chocolate, we're going to be having it with fat and sugar. So yeah, we've got those combinations. Okay, so I mentioned that we're also going to be talking about some other aspects of chocolate. And while the world's eaters of chocolate tend to be in Europe, Europe is way too far north for chocolate to be eaten, or not eaten, grown. You just can't grow a cacao tree in Europe or in North America. Mostly you have to stay right around the equator. So this belt in here is roughly where the Tropic of Cancer and the Tropic of Capricorn are. So minor foray into some, I guess, astronomy. As we go around the sun, we're tilted at an angle. And so the sun hits directly at the equator in the springtime and in the fall. But when it gets to the summer, it's hitting a little bit above the equator. So in June, the sun hits directly here. And in the winter, it hits directly here. And that's why southern part of the world has opposite seasons from us. So Australia, their winter is when our summer is. South America, similar. But in this band in here, that's where the sun is pretty high in the sky all year long. Now, for us, when it gets to be winter, the sun gets so low in the sky that even at noon, it's like it's right in your windshield and like you kind of blinded by the sun all December long. But for these countries, it's way up high. In the winter, we have very long nights. So it might get dark around 6 p.m. and then it might stay dark until 8 a.m., right? I did spend a little bit of time in France over the summer when I was in high school. And when I was there, it would be 11:30 at night and it would still be light outside. Okay, so we have those extreme changes. Near the equator, you have 12 hours of daylight, 12 hours a night. Might shift to, 14 and 10, but like you're pretty consistent year round. But it's also very warm. all the time near the equator. So consistent sunlight and very warm. And that's where you can grow chocolate. So I had mentioned before, I kind of spoke off the top of my head and I said this incorrectly. Chocolate was first grown here in South America and in Mexico. And that's kind of where Europeans discovered, brought it back, realized we couldn't grow it there. And then during all of the colonialization that they were forcing upon the rest of the world, they ended up finding in these countries in here, particularly Ghana and the Ivory Coast, were really good places to grow chocolate. Okay, so what's the consequence of that? People want what they want, and they will, do whatever makes economic sense. And economic sense means not paying people what they deserve to be paid. So the regions that are best for growing chocolate tend to include some of the poorest regions of the world and vulnerable populations. And so a lot of the chocolate that is sold in the world comes from areas where there may be farms where they have lots of cacao trees, where they may be essentially having slave labor. They may sometimes abduct children away from their families in order to work in these places, or they may, the children may be sold by their families in order to have enough money to support the rest of the family. So this is kind of the side that is very unpleasant about chocolate. And so that does lead to exploitation and slavery. Some of the other problems are, in order to grow a lot of chocolate to feed everybody, as much as, our greedy American and European people want, you got to have lots of fertilizers. You got to keep the trees free of pesticides. And so, you can find videos of kids that are 8, 10 years old, no masks, no gloves, carrying around pesticides, spraying trees with these. And these are kids that they're not done growing yet. And so these pesticides can be affecting their growth and their mental development, in addition to being toxic as well. So that's something to keep in mind. So I mentioned Ghana and the Ivory Coast are two places where there's a lot of chocolate that is grown. And so what ends up happening is that when you have a lot of poverty in an area, a lot of times you can have the families that they just need fewer people to feed, or they need more money. And so rather than having the kids go to school, it makes more sense to have the kids work in these areas. If they're not working locally, then the family doesn't have to feed them. They can, essentially have the kid sold to somebody else. But even if they are working locally, they can be bringing home money. So that poverty really kind of makes that situation far worse. Most chocolate companies are getting chocolate not from one localized farm for chocolate. They're getting it from lots of different areas. And companies have tried to work with the countries and the chocolate factories and whatnot within these countries. And it is very, very difficult to say this chocolate came from this place and we know this place has fair practices. And there tends to be a lot of corruption in those places as well. They say, oh yeah, we swear everything's good. None of this chocolate comes from, those places. We know that there's bad practices at farm X, but we don't buy from them. We're buying from other ones, and trust us, your chocolate is good. So it's difficult to suss those things out. So we got some statistics here. 1.5 million children are in child labor. We've got a picture here. You probably can't tell what it is, but this is one of those kids using the bags that have the pesticides and spraying the pesticides. They're doing hazardous activities. Cacao trees don't grow very tall, but in order to get the pods, which are like this big, off, they have to use really sharp knives to cut them down. And they're of course told you have to work rapidly. So you can imagine a bunch of 8, 10, 12-year-olds running around with sharp knives. This is not always everybody coming home with all of their fingers and hands and arms intact. And let's see, 62% is the increase in cocoa production between 2008 and 2018. So you like our chocolate, we're gonna keep asking for more of it. And so here are some of the things that I've mentioned. The kids not being in school, the kids working in dangerous situations. So there are some groups that try to certify fair practices. And so you can find labels that might say fair trade or Rainforest Alliance. And so rather than buying from a collective, they buy from a specific farm. And so they will try to ensure that those farms are not using children. And so therefore, we're bypassing that issue of the children working in dangerous situations. They try to ensure that the farmers are getting adequate resources and whatnot from their communities. And then they're given a fair price rather than the rock bottom price for their goods. Rainforest Alliance is similar. They tend to work more in South America rather than in Africa, but I don't know as much about them. So those are two labels that you can find. They're not the only ones. You can get chocolate that has not been a part of this sort of exploitation, but it does tend to be quite a bit more expensive. And one of the things that I find is that when I'm trying to find chocolate for a special thing, it's difficult. So like I can get cocoa powder to make, cookies or hot chocolate or whatever, like that's not hard to do. But, if I know somebody who, really likes Reese's peanut butter cups, well, that you can't really get that particular kind through these fair trade practices. There's one company that does them, but it tastes weird, the combination that they have. So you have fewer options. You can't get a Snickers bar that way. You can't get your Milky Way that way. So, there's that. If you're shopping for your Easter candy that, you're going to fill your basket and help out the Easter bunny that way, it's harder to find those kinds of specialized candies. And they tend to be expensive. All right. So we got the chemistry side of chocolate. We've also got the social aspect of chocolate to keep in mind as well. So I love chocolate, but I do try to stick with the fair trade stuff. Okay, any questions about chocolate? Okay. That's not what I want to do. I want to do that. Okay, so the last topic that we're going to hit in this chapter is on alcohol. There. Okay, so we talked about alcohol as a functional group. So when we have this OH hanging off of a carbon, then that means that we have an alcohol group. So remember when we have these line drawings, the corners are carbons. So this is attached to a carbon and the ends are carbon. So this has two carbons and it has an alcohol group. So, so this is ethanol. Ethanol is what we typically call alcohol when we're talking about alcohol in food and in medicine and in flavorings and things like that, that we're almost always referring to ethanol. There are other alcohols you've probably heard of. You've probably heard of methanol, which is sometimes it's called wood alcohol. That is used as a solvent in different kinds of things, which means it helps to dissolve stuff. So if you work with paints, if you work with things from Lowe's and Home Depot, if you work with propellants, so like things that you might spray, sometimes methanol is used for that. And then isopropyl alcohol, that would be the rubbing alcohol that you would get to clean wounds and things like that. But this one is ethanol. So I will expect you to know the formula or at least be able to recognize the formula. So if I show you this formula and say, what is this? This formula, CH3CH2OH, or we can combine those to make it C2H5OH, that is ethanol. Methanol is very, very close to the size of water in polarity. of water. Ethanol is a little bit bigger and a little bit less polar, but it's still very similar. So we can do, they are what we call miscible. We can mix them in any ratio. So I can have, absolute vodka technically would be 100% alcohol. It almost never would be. Or I could have, just a splash of alcohol and a whole bunch of water. And I can do everything in between. Okay. So they are miscible because they mix together really well. It's found in a lot of things. So of course we think of fermented beverages, beers, wine, sake, ale, mead, all of those things. It's also used as a preservative in fruitcake. So I was really surprised a decade or so ago when my mom told me, "Oh, I love fruitcake. It's got bourbon in it." I was like, I didn't know anybody liked fruitcake, but hey, if it's got bourbon in it, more power to you. Any kind of food flavoring that you add to things, vanilla in particular, but if you're adding vanilla, if you're adding banana flavor, if you're adding peppermint, they're usually in preservatives of ethanol. Sometimes it would be in cough syrup as a depressant not because it's going to make you sad, but because it's going to help you sleep. Yeah. And then there are sometimes ethanol found in gasoline. So you can find some gas stations where they'll advertise what % of their gasoline is ethanol. So those are some different places you can find it. And then the way that we measure how much is in there is kind of a weird way. It is called proof, and it's twice the percentage. So the idea is that when alcohol, particularly when it was banned, but also when it was just hard to come by, sometimes people would mix other things together or they would water it down. So they might take, oh, well, this is a really great whiskey, but if I divide it into, 10 parts and dilute it with water and sell it to people for the same price, I can make more money. And so in order to prove to people that it had the alcohol content, they would put a small part of it on paper and try to light it on fire. So you have to have about 40% to be able to catch something on fire. And so that's why it's called proofing. So whatever the proof number is, divide it by 2, and that's what the percentage. So 100% ethanol would be 200 proof. All right, so that's where I'm going to pause on there. What I want you to do at this point then is to start getting your numbers up on the board so other people can get down their numbers and we can kind of look at what the effect of this chocolate caffeine scenario has been on you.